Hello, and welcome to your first remote lesson in Intro to Programming. So, what I have up on my screen right now is a Google Sheet. Um, Depending on whether or not you've taken freshman computers, you may or may not be familiar with Google Sheets. You may or may not be familiar with Microsoft Excel. But we are going to use it in the beginning of our course as a way to sort of introduce different programming concepts. Um, we're going to see that it can we can write like small little programs with it, and it sort of helps us illustrate some concepts without having to learn an entire programming language. So it's kind of nice in that respect. Now, for today's activity, there's a few skills that you're going to need. Um, and again, depending on your familiarity with this, you may or may not know how to do those things. So what I'm going to start with is just a quick demo of some of the skills that you're going to need to be able to carry out this activity. So first things first, you're going to need to be able to make a graph. All right. The lab activity that you do today is going to require a couple of different graphs. So I want to make sure you're comfortable with that process. So when you do the lab, you will have two columns of data. Here I just made up two columns of data, X and Y, but they'll work just the same. You start by highlighting the data, including the headings. All right. So I've just highlighted my data, left click on the X, and then drag to highlight everything. You then go to your insert menu. You then go to chart. All right. Now, if you're lucky, it's going to choose scatter chart for you. All right. It tries to figure out what you want based on the data that you have. If it doesn't, then it would be your job to just go over here and change it to a scatter chart because that's what you are going to need for this lab. All right. So you're going to want the scatter chart. Everything else you don't really have to worry about. We are going to use the scatter chart. There's like other options in here to customize it and make it look pretty and add headings and all that other stuff. For this lab, we're not really concerned about making a pretty graph. I just need a very simple scatter chart. You don't have to worry about anything else. If for whatever reason it accidentally flips the X and the Y, there is a box that you can have it flip it back and forth. But it shouldn't do that. It should be good to go as soon as you highlight it, click insert chart. The only thing you might have to change is the chart type if it picks the wrong one. All right, so once you have this chart, you're going to be copying and pasting it into a Google Doc. Now, most of the time when people try to copy something, they right click. All right. In Google Sheets, you don't right click, you click on these three little dots, and there will be an option to copy the chart. So you're going to click copy chart. All right. You're going to go over to the Google Doc, and then where it asks you to paste the picture, now you can right click if you want. You can choose paste without formatting. I'm sorry, don't choose paste without formatting, just choose paste. And then when it says whether to link or to unlink, we want it unlinked. All right. If you have it linked, then if you change the spreadsheet, it changes the picture. And I'm actually going to ask you to paste a couple of pictures, so I don't want them linked because then they'll all end up looking the same. So when you paste it, choose paste unlinked, and then it'll paste the picture into the Google Doc. All right, so that's skill one that you need to be able to do in Google Sheets. And again, it's pretty straightforward. You just highlight the data, click insert chart, and you should be good to go. All right, not a lot to do there. The second piece is doing what are called calculations and references. All right, so in Excel, you can think of it as a giant table or Google Sheets. Sorry, I'm probably going to say Excel a bunch. Excel is the Microsoft version. Google Sheets is the Google version, but I'll probably accidentally call it Excel all the time. You can type in any of these boxes, which are called cells, but you can also insert a little program into one of these boxes. All right. Now, they're not always going to feel like programs, but that's effectively what they are. They're mini little programs. And anytime you're starting a program, it has to start with an equal sign. All right. That's how Sheets knows that you're about to write a program. And a very simple program we could write is something like 5 plus 3, right? Or 8 times 7, or 5 squared, which is the caret, and then just typing the number 2. Or if we wanted to take a square root, we could go equal SQRT, left parenthesis, 36, and that will take a square root for us. So right now, it just looks like a calculator, but we are going to be able to write more involved, more intricate programs inside of this. Now, lesson 1 about programming. Rarely, if ever, do we hard code numbers into our program, right? And the reason we don't hard code numbers into our program is we want our programs to be flexible, all right? And if you hard code numbers into the program, that means anytime you want to run your program on different numbers, you have to go in and change the code, which is something we usually don't want to do because it could introduce errors, it's time consuming. Instead, programs use the concept of variables, which is where instead of saying, oh, I want to add 5 plus 3, we might say, oh, we want to add x plus y. And the advantage of that is just by plugging different numbers into those variables, we can get different results without ever having to change the code. All right. Now, there's a similar feature in Sheets in Excel. All right. So I'm going to go up here to where it says add, and I'm going to say equals. Now, instead of typing in 4 and 6, what I'm going to do is I'm going to click on the number 4. And when I do that, it might be hard to see, but this is filling in E2, which is the location of this 4 in the spreadsheet. It's in column E, row 2. Then I'm going to type the plus sign, and I'm going to click on this box, which again, I could have typed it in manually and typed in F2, but if you click on it, it automatically fills it in. And now my program is saying equals E2 plus F2. You can think of that as equals X plus Y. Now, when I hit enter, it just gives me the 10, like I was expecting. 4 plus 6 is 10. But my program is now more flexible. And again, it might not seem like a program, but it's a tiny mini program. And by flexible, here's what I mean. If I go in and change these numbers, my program automatically updates the answers. All right. If I change this number, it automatically updates the answers. And that's what I mean about making a program more flexible. All right. By introducing this idea of variables, we can run the program multiple times with different values without having to change the code over and over and over again. So again, this is just your chance to practice if you haven't done a lot of this. So I could do this box minus this box and make sure I'm getting the right answer. I could do equals this box times this box, make sure I'm getting the right answer, equal this box divided by this box. I'm going to get a decimal. And then exponent, again, is the caret, which is shift 6. So I can click on this box, shift 6 for the caret, click on the 54, and I'm going to get some giant number there. 30 to the 54th power is pretty huge. All right, so that's concept 1, is programs use variables, and we use them so that our programs can be more flexible and we can run it with all sorts of different situations and not have to change the actual code. The other thing that's very common in programs are loops. All right, now you saw the loops when you did the Angry Birds exercise. Right? Instead of having to write the same code over and over again, we can use a loop, and the loop repeats the code for us over and over again. So let's say I wrote my program here that was X plus Y, and I wanted to repeat that program for all of these boxes. All right. There's not an actual loop in Excel like there is in programming, but there's something called the drag down, and the drag down works pretty much like a loop. To access the drag down, you have to bring your mouse to that lower right corner of the box. And when you do that, you should notice that it changes from the pointer to like a giant plus sign. All right, if it's on the giant plus sign, that means you're in the right spot. If you then left click and drag down, what that does is repeat your program over and over and over again. So originally your program was adding together box E2 and box F2. When you drag it down, it then adds together E3 and F3. If you keep dragging it down, E4 and F4, E5 and F5, E6 and F6, and then so on and so forth. So it gives you that looping behavior where you wrote a program and then you said, all right, let's repeat that program over and over and over again. And again, this would not work if you hard coded in the number. If I said equals 6 plus 7, and then I tried to drag that down, it's just going to keep doing 6 plus 7 over and over and over again. All right. So I don't get to take advantage of that efficiency that I can get by using variables. But for each of these, I can go in, left click, drag it down. Left click on that bottom right corner, drag it down. Left click, drag it down. Left click, drag it down. So again, programs often do the same things over and over and over again. And when we're doing those things over and over and over again, we want to let the computer repeat it. We don't want to have to write the same code over again. So loops and variables can kind of go hand in hand. The variables let us make things more flexible. And then the loops allow us to repeat that over and over and over again, so that we don't have to code the same thing a million different times. All right. Now, the last thing I need to show you in here before we move on is what's called an absolute reference. All right. So I've got this column of numbers here, 10, 3, 24, 4, 50, 532, 32, 2. And then I've got my magic number down here, which is 7. There's not really anything that magic about it. It's just the number that I chose. So let's say I wanted to add 7 to all of these numbers. Now, you might be saying to yourself, well, you could just go equals, click on the 10, click plus 7, and you're good to go. Yes, except then if I wanted to change my magic number, I'd have to go in and change my code, which is something I don't want to do. I want to make my code as flexible or robust as possible. So instead of using a 7, I'm going to click on the box. All right, so I'm saying N2 plus N13. Then I'm going to hit enter, just like I did before. Now, if I drag this down, you're going to see that it doesn't actually work. All right, this stays at 3, this stays at 24, this stays at 4, this stays at 50. The reason it doesn't work is that when you drag down, it drags down all the boxes that you clicked on. So I originally said 10 plus 7. I said this box plus this box. When I drag it down, all right, it drags this box down to the 3, which is what I want, but it drags this box down to a blank square, which I don't want. All right, so we've got to fix this. Now, you might be saying to yourself, well, couldn't you just put a whole bunch of 7s there? Yes, I could, but then if I changed my number, I'd have to change my number in a whole bunch of places. And again, we're trying to be as efficient as possible so that our program is as flexible and easy to update and easy to maintain and all those other things. All right, so instead, what we're going to do, I'm going to start with my equal sign, because we always start with the equal sign. Oops, actually, let me start way back up here at the top. I'm going to start with my equal sign. I'm going to click on the 10. I'm going to type in my plus sign. I'm going to click on my magic number. And then what I'm going to do is I'm going to hit function F4. All right. Now, at the top of your keyboard, you should have an F4. But on laptops, they usually want to save space. So there's usually a separate FN key that you have to hold down and then hit F4. I don't know how your laptops are set up, whether they have their own F4 key or not. But if they don't, you have to hold the FN key and then hit F4. And you'll know it worked if those dollar signs pop up. And if you hit it again, the dollar sign's just in front of the 13. You hit it again, the dollar sign's just in front of the N. You hit it again, they disappear. We're going to want it so that the dollar signs are in front of both the N and the 13. Now, if you can't get the FN to work, you can just type those dollar signs in manually. All right, I could click on the N13 and then click back up here and type in a dollar sign and then click in front of the 13 and type in a dollar sign. And what that does is it locks this N13 box in place. So when I drag this down, the orange box will slide down, the purple box stays locked in place. And you can see if I click on each one of these, the orange box is moving down, the purple box is staying in place. So these absolute references give you a way to sort of lock things in place. And again, these columns are just a chance for you to try that. So I click on 10, I subtract this box down here, I hit F4, and then if I drag it down, I should get all of the right answers there. Same thing here, click on the 10, type in a multiplication sign, click on the 7, hit F4. And again, just your chance to sort of make sure that this is working and make sure that you know how to do the reference and some additional practice on kind of dragging things down. Again, if you've taken freshman computers, hopefully this is all review. But for those of you that haven't yet, this might be brand new. So I just want to make sure that you've got an example of how it works. And then again, we can drag it down. All right. So that's some of the basics that you're going to need to be able to do today's activity. You're going to need to be able to make a graph, and you're going to need to be able to do some of these calculations. Now, let's look at a more involved program. So I'm going to go over to this second tab here, where we are going to write a program that does the quadratic formula. Now, depending on whether you've taken algebra or not, you may or may not have seen this formula. But this is a formula that gets used in algebra. It's used to find the roots of a quadratic equation. So what we're going to do is we're going to write a program that does this formula for us. All right. And if we set it up correctly, we're going to be able to very quickly do all 10 of these problems. All right. And that's kind of one of the reasons we write programs. We write programs to help us accomplish a task. So instead of doing the quadratic formula 10 times by hand, let's write a program and then let the program just run again and again and again and again and again on all of our different problems. All right. So again, that's kind of the idea of what we're doing here. So I'm not going to get heavy into the math here, but when you have a quadratic equation, the number in front of the x squared is considered a, the number in front of the x is considered b, the number all by itself is considered c. So all I've done down here is from these equations, I've pulled out the a, the b, and the c. So like on this very first one, the a is the 3 because it's in front of the x squared, the b is the -2, and the c is the -5. And again, the math part, if you know it, great. If not, it's not a big deal to what we're doing right now. But we're going to write this equation as a little program and then use Excel or Sheets to run it again and again and again and again. So we could write this as one big long program inside of a single box, but that's going to make it harder to debug or harder to find a mistake. All right. So instead, we're going to break it down into small little pieces. We're going to make sure that each small little piece works, and then we're going to tie it all together at the end, which is the approach you want to generally take when writing a program. Don't try to do it all in one big step. Break it down into little pieces, test each step as you go, and then at the very end, you can combine it into one final output. All right, so step 1 says we're going to do this part of the formula, b squared minus 4ac. So we're going to start with an equal sign. Now, b squared, we're not actually going to click on the b, we're going to click on the number underneath the b. So there's me clicking on the -2. The squared part is shift 6 to get the caret. Now, this is one place where we can just code in the exponent. All right, it's always going to be b squared. There's no reason that part would ever be changed. So we are just going to hard code in the 2 at this point. Then we're going to do subtract. Again, we're going to hard code in the 4 because it's a specific formula that we're coding in. And that formula always has a 4 there. The 4 never changes. Then we're going to type a multiplication symbol. We're going to click on the A. We're going to type the multiplication symbol. We're going to click on the C. And hopefully, when you do that, you're going to get the answer 64. If not, rewind the video, try to figure out what went wrong. All right, step 2. Again, we're going to start with an equal sign. Step 2 is taking the square root of the calculation we just did. So we're going to do SQRT, left parenthesis. That's how it knows to do a square root. Now, we're not going to redo that calculation. We're just going to click on the 64. All right, that 64 is this calculation. So we're just going to click on that. You can close your parentheses and then hit enter. And you should get 8. And then the last one here is pretty easy, 2 times A. So we're just going to equal 2. And again, that can be hard-coded in because it's part of the formula. And then we can click on the A. And we've got the 3 pieces that we need. We have the B squared minus 4AC, we have the 2A, and we have the square root. We could break it down further, but now we're going to kind of combine it into an answer. Now, the quadratic formula, this plus minus, is just because there are 2 answers. You have to do it once with a plus, once with a minus. So as you can see, it's an annoying formula, and it would be nice to have a program that does it for us. So our very last step is going to be equals. Now, Sheets, Excel, whatever, follows order of operations. So to get it to do it in the right order, we're going to need parentheses. So we're going to do a left parenthesis, a minus sign, and then we're going to click on the B. That's the negative B part of our formula. Then we're going to do plus. And then this whole square root of B squared minus 4AC is this box right here, F13. So we're going to click on this box. We're going to close the parentheses. We're going to hit the division key. And then we're going to divide by 2A. But again, we've already done that calculation. So we're just going to click on this box right here. And then we're going to hit enter. Over here, we're going to do the same exact thing, except instead of doing plus, we're going to do minus. So I'm going to start with an equal sign. I'm going to need the parentheses so that it does it correctly. I'm going to type in a minus sign, and then I'm going to click in the B. That's our negative B. This time I'm going to do subtraction instead of addition. I'm going to subtract the square root of B squared minus 4AC. So I'm going to click on this box. I'm going to close my parentheses. I'm going to type the division key, and then I'm going to click on my 2A calculation, which is this 6 here. All right. And then if I hit enter, I get my answer. Now, that might have seemed like a lot of work, but the upside is because we coded it with variables, we now have a flexible program that we can just drag down. I can click on this box, drag it down. I can click on this box, drag it down. Click on this box, drag it down. And I can actually highlight all 3 of these at once and drag them down together. Or you can do them one at a time. Either way will work. Same thing over here. I could highlight both of these and drag them down together, or I can do them one at a time. And yeah, it took a little longer to set up the program at the start, but then I can pretty much do the next 9 instantaneously. And if I had 100 problems, I could do those 100 problems instantaneously. And that's one of the reasons we write programs, right? Is to take things that are tedious to do by hand and allow the computer to do them for us. And as long as we set up the program using variables, using flexible inputs, we can then take advantage of looping behavior to allow it to do the same thing over and over and over and over again. All right, so that's kind of the big idea of today's exercise is 1, the use of variables to make things more flexible, and then 2, taking advantage of that flexibility by allowing it to loop through the same things over and over and over and over again. All right? So that sort of brings you to the day's activity or the day's lab. All right, the very last tab down at the bottom is going to be where you are writing a little program. All right, and you are going to be writing a program that models how things fall through the air. All right. Now, why that? All right. So think about any of the games that you play. All right. Let's throw out, like, if you know the game Smash Brothers. All right. You've got characters jumping all around the screen. You've got characters moving up around the screen. You have characters getting hit off the edge of the board. You have characters falling. All of that is basically physics equations. So like equations that are part of a physics course describing how objects move through time and space. All right. Physics is very good at explaining how objects move, how objects accelerate, how objects fall. And video games and computer programs take those equations and they program them into their games or their apps or whatever to simulate behavior. All right. If you're moving around a virtual world, you want it to feel kind of like the real world. All right. So the science of physics has a bunch of equations that describe how things move in the real world. So if we encode those equations into our programs, then the objects in our program will move the same way things move in the real world. All right. So that's effectively what you're going to be doing in today's activity. You're going to be coding this equation into Google Sheets, and then you're going to be using that equation and changing some of the values to see how things move and see how things fall through space. So the sheet that you've got is going to walk you through this whole process. All right, so there's a little introduction here. It says the computer screen is basically a giant piece of graph paper. Objects are moved around by changing their XY coordinates. So when you have a character on a screen, a program makes that character move by changing those XY coordinates at a fixed interval to make it look like it's like smoothly moving. We don't want to have to manually specify every movement, so we use formulas and variables. All right, we don't want to have to say, move to this spot, tend to this spot, then to this spot, then to this spot, then to this spot, because if we wanted to move them in a different direction, we'd have to go in and manually change all those things. So instead, we're going to use a formula to control their movement. All right, so this formula right here controls how things move due to gravity. So like if you push something off a ledge, this formula is going to show you how that object moves. All right, SO is the starting position, VO is the starting speed or velocity, T is the time, A is the acceleration. So you're going to use Excel, again, or Sheets to create a program that implements the formula. While the games on your phone don't use Excel, it's possible they have a similar equation written into their code. So this sheet will walk you through exactly how to set up the formula. All right, but you have to make sure that you read it carefully and follow the directions. So in cell A13, we're going to put our first formula. So that means you're going to type the equal sign, just like I did in all those demos. You can either click on box A12 or you can type in A12 plus B5. Again, you can either type in the dollar signs or use the F4 key to put them in. And then it tells you how far to drag it down. So you're going to drag it down to row 37. It then tells you the next formula that you're going to put in, and it tells you where to put it. It tells you that the next formula to put in, and it tells you which ones you're going to be leaving blank. And again, there's the formula, and so on and so forth. All right, these cells are going to be blank. You're going to put the formula in here. You're going to end up with this calculation. All right. Once you have completed all of those calculations, your spreadsheet's going to be filled with all sorts of numbers. And again, those numbers kind of indicate where an object would be on the screen or in real life. You're going to use those numbers to answer some questions. So you're going to make a scatter plot, which again, I demoed on the first one. You're going to tell me when an object is hitting the ground. Right? If you're making a game, it's important to know when the object hits the ground. You're going to let me know what speed it hits the ground at. You know, if you're going to have it like bounce off the ground, you have to know what speed it's hitting the ground at. Then we're going to have a couple other simulations. We're going to change some values. And because we used variables, when you change those values, you're going to see that all of the calculations instantly change. All right. You don't have to go back and redo stuff. You just change these numbers in these spots. It tells you where to change them, and your program is instantly going to update. Then you're going to answer some more questions. And then last but not least, you're going to mess around with gravity. All right. So gravity changes based on what planet you're on. So there's a constant for gravity on Earth, but that constant is different for Saturn and it's different for Jupiter. And if you're making a game, that constant could be whatever you want. You want the character to be able to jump really high, you're going to change gravity and you're going to make it smaller. You want the character to be hardly able to jump at all, you're going to crank the gravity way up. And when they code these into their programs, it becomes much easier to tweak the game just by changing one or two values and having everything else automatically update. So that's going to be your activity for today, is trying to code in this program by following the directions and then using your program to answer the questions that are on this sheet. All right. So hopefully this was helpful. Hopefully it answers any questions. If you run into problems, send me an email, and I will try to get back to you as soon as possible. All right. That is it. Have a great day.